In this video, we want to prove the following inequality, and what we actually need to do is prove that the left-hand side is equal to the right-hand side. Now, when you approach these types of questions in trigonometry, I recommend that you start with the left-hand side because we can see there's some sort of calculation or factorization that we can apply here. So what I would write down is I would say the left-hand side is equal to sine theta minus cos theta times sine theta, and divide that by cos theta minus 1 sine squared theta. So I'm basically just copying the left-hand side over. Now when I inspect the numerator, I see that sine theta is a common term, and I also see that there are two terms. Remember, the terms are separated by either a plus or a minus. So if sine theta is common, that means I can factorize with sine theta. So in the numerator, I'll take out sine theta. And if I take out sine theta in the first term, I'm left with 1 or a placeholder. And in the second term, if I take out the sine of theta, I'm left with cos theta. And that's all I can do in the numerator for now. Now let's inspect the denominator. And I notice there's not a common factor, but I have 1 minus sine square theta. Now this should point you towards one of the identities. So remember that sine square theta plus cos square theta is equal to 1. And if I take over this sine square theta, I will have cos square theta is equals to 1 minus sine square theta. That means that in our denominator, that 1 minus sine square theta can be rewritten as cos square theta. So I'll have cos theta minus cos square theta. And now in our denominator, we can see that we have a common term of cos theta, so we can factorize out cos theta. So when I factorize out, I'll always copy the numerator, the top part of the fraction first, because there's nothing else to do. And then I'll factorize out cos theta. So in the first term, if I take out cos theta, I'm left with 1. And in the second term, it is cos square theta. So I'm taking out one of those cos thetas, so there's still a cos theta left. Now you can notice that in the numerator and denominator, we have 1 minus cos theta. And that actually will cancel out, and we are left with sine theta over cos theta. Now again, this is one of the identities that you have learned, that tan theta is equals to sine theta over cos theta. So therefore, the left-hand side would be equal to tan theta, and that is what we wanted on the right-hand side. So when we present our working, always start with the side that you've chosen to work with. So in this example, I chose the left-hand side, and I show all my calculations up until I manipulated the left-hand side to look like the right-hand side.